In this video note, we're going to introduce some of the key terminology of object-oriented programming. The first piece of terminology we want to introduce is the word class. This is probably the single most important concept you will learn about in this video note, because it is impossible to discuss object orientation without a firm understanding of the meaning of the word class. Class is actually a concept that you will already be familiar with from everyday life, which will make it relatively easy to understand in the context of object orientation. However, we typically use other words than class in everyday speech when referring to this concept. Words such as type and category. To begin our introduction to what class means, suppose I say the word bicycle. Immediately you will know exactly what I mean by that word, and you will probably get a mental picture of one. What is interesting is that not everyone watching this video will have the same mental picture, but everyone's picture will fit the description bicycle. Why is this? It's because the word bicycle describes a general category or type of things. Vehicles having two wheels, ridden by people sitting down, and powered by legs using pedals. And that description is sufficient in itself to convey a shared understanding of what we're talking about, the general features of bicycles. What we might refer to as a category or type in everyday language is referred to as a class in object-oriented programming. A class describes the general shared features of things, the features that make something what it is. We could apply the same process to lots of everyday items. The word chair, for instance, conjures up a mental picture of something to sit on. Car means to everyone something with four wheels and an engine that is driven, and so on. What is missing in all of these examples is a satisfactory description of any particular bicycle, chair or car. If you own a bike or a car, what colour is it? Is it clean or dirty? Is it large or small? The concept of class cannot answer these questions for a particular example of the class, because each individual example may be slightly different from each other. While the class might have provision for recording colour, size and cleanliness, those questions can only be answered on an individual basis for particular bikes or cars. So we need another concept to talk about individual examples of a particular class, and this is where we get the word object that gives object orientation its name. An object represents a particular individual example of a given class. While each object that belongs to a class will have the same set of characteristics, because that is what it means to belong to a class, the particular settings or values of those characteristics will be particular to each individual. One bike might be red and another blue. Two different bikes might both be blue, but one might be clean and the other dirty, for example. This doesn't mean that two objects cannot have the same values for their features. Bikes coming off a production line at the same time are likely to all be the same size, colour and be clean. But it does mean that the settings of those characteristics are independent for each object. We shall shortly see how this works in the world of programming when we look at our first program example in the ofwj programming environment. However, there is one final piece of terminology to introduce at this stage, the word instance. This is commonly used interchangeably with the word object because instance and object mean pretty much the same thing. However, instance is often used when we're referring to a specific class. For example, we might say that this object is an instance of the circle class. In summary, a class describes a general category of things. Individual objects are created from a class, and each created instance possesses its own copy of the characteristics of its class.